Okay, so as I said in chapter 4.1, we're going to use an already trained, and you'll understand what training is later on, but you're going to use something that we actually create in this course in the next couple chapters to classify handwritten digits. So it's going to be pretty cool. So let's get started. Okay, so let's bring up our development environment, and that's source activate CV. And now let's bring up our IPython notebook. So let's type IPython notebook. And there we go. Mozilla should launch, and we should have basically our home folder information here. So let's go to deep learning, which is where all our projects, or 90% of our projects, are located. And let's go to chapter 4, which is our first chapter. As you can see, all the chapters are here. And let's open this one. And it should bring up this. This is called an IPython notebook. And I've left some simple notes here, some comments here. This one, I'm not going to actually teach much from this course here, from this code here, sorry. I'm just going to actually execute it, and we get to see what it does. So basically, before I begin, let me just briefly discuss the code. These are our imports here. We're importing OpenCV, NumPy, which is our array processing library, and Keras, which I'll teach you about later on. Keras is basically the framework, the deep learning framework we use to basically control and operate TensorFlow, which runs in the background. And that does all our deep learning stuff. So we're loading the MNIST dataset here, and that's how we're importing this from Keras here. Loading our model, and then this is a function we use to basically draw the prediction, what our model makes, over the actual digits. And you know what? Let's just actually run this and see how it works. So it's loading. This asterisk here means it's loading. Ah, there we go. So now we have basically what this does. It brings up a number from a test data set. Test data set is basically images that the the deep learning algorithm has not seen. And basically it tells you that it never saw this digit before in its life, but it tells you it's able to figure out that this is a 4. So now if you press enter, it goes through another image, and it basically does this up to 10 images here. You can go up to 50, 100, 1,000 if you want. Although I don't recommend going up to 1,000. This is a 2. Actually, this is pretty good. It's an 8. Good. 1, 1, 6, 8, 3, 5, 6. Perfect. So it appears this model that I trained here, called MNIST Simple CNN, is actually quite good at reading our numbers, sorry. So can this work on real numbers now? What do I mean by real numbers? Well, let's find out. Let's run this. If I didn't mention it to you before, Enter and Shift on a keyboard together basically executes the code in the cell block. I should have mentioned that in the beginning, but now you know. Okay, so this is numbers that I actually wrote and took a picture with my phone. And basically the code I've done here, it basically uses OpenCV to extract the digits here. And then it pre-processes it to basically make it look as similar as the training data for the MNIST dataset looked. And let's see. So basically what it did, it took out this one, and you previously saw how the MNIST dataset images were basically grayscale and white on black background. So it picked this out, extracted it here. This is a contour we drew over it here, and immediately it classifies this as 1, and it puts a 1 here. So that's pretty good. Let's see if it gets a 3 correct. Bingo, got the 3 exactly right. Got the 5 exactly right. 4, 0, perfect. So all of this here is my OpenCV code, and if you want to understand how this code works, I'm not going to explain it to you thoroughly here, but this should be fine. But I'm actually going to tell you that if you do want to learn this, look at my OpenCV tutorial. It'll teach you all of these things, what Gaussian blur, canny edges, contours, how these things work, how to use functions, and you're sorting your contours here, how to actually sort contours and bring them up and extract them, and then feed them to a classifier, which is what we're doing here, the same classifier we used up here. So we're pretty good. You just actually use a handwritten digit classifier that I built, and you're going to build it soon. Actually, perhaps you can build it right now. This is a code where I'm not going to go through in detail, as I said, but this is a code that actually allows you to train that classifier. It is not as complicated as it looks here. If you're unfamiliar with it, I expect you to be a little confused. What the hell is batch size? What are epochs? What is going on here? Blah, blah, blah. But don't worry, all of these things will be made very simple soon. And basically you'll understand what these lines mean here, what this means here. This is actually our accuracy of our model, 99.07, which is pretty good. Not top of the line state of the art, but pretty good. And stay tuned, you're going to learn how to do this in the upcoming chapters.